All right, welcome to the lesson on solving quadratics by factoring. We have a warm-up to start here, so go ahead, pause the video, try the warm-up, see how you did. Okay, so I don't like how I disguised it, but it's fine. Here's all my work, all right? And here are the answers. So the first one there, simplifying, you should have x squared minus 2x plus 15 all over 6x minus 30, or 6 times the quantity of x minus 5. And then for B, you should have x equals 45/4, or 11 1/4, or 11.25. Notice the x values of +4 and -4 wouldn't have worked if we got them as solutions, but we didn't get those as solutions. Okay, so our whole goal today is to solve a quadratic. And one of our ways to solve a quadratic is by factoring. So like this is our goal down here. Those are examples, but in this section, it's making sure we know how to factor, okay? So just to run through a few things really quickly, when factoring, the first thing you always look for is a GCF, a greatest common factor. If it has a GCF, you factor out. If not, you move on to the next. So for the next, you look at how many terms it has. If it has 2 terms, you're gonna look to see if it is a difference of squares or a difference of cubes or a sum of cubes. If so, you're gonna factor that. If it's 3 terms, you're gonna look to see if you can factor it using whatever method you'd like as far as that video that I made before. So you could either use guess and check, you can use bottoms up, you can use factoring by grouping by splitting up the middle term. And then if it's 4 terms, you are going to try to factor by grouping, okay? All right, so let's see how we do here. All right, so this says the directions are factor, not solve. So you are factoring, your answers are factors, right? Looking for a GCF, there is no GCF. This is 3 terms, so I use the organizational method of making an X right here. Then A times C goes up top, that's -48. B goes on the bottom, that's -2. I'm looking for 2 numbers that multiply to give me -48 and add to give me 2. That's -8 times 6. Since the lead coefficient is 1, I don't have to worry about dividing it by anything. And then my 2 factors are x minus 8 times x plus 6. And I can always check it by multiplying it out, but I'm pretty confident. All right, the second one here, first thing I look for is a GCF. These three terms have a 2 in common, so I'm going to start by factoring that out. And now I have a trinomial left inside my parentheses, so I'm going to try to factor that. So for the trinomial, I'm not looking at the 2 here, I'm just looking at this, okay? I'm looking for 2 numbers that multiply to give me 18 and add to give me -9, which are -6 and -3. Since the lead coefficient is 1, I don't have to worry about dividing that out. So I don't forget about this 2 here, otherwise it's not an equivalency. 2 times y minus 6 times y minus 3. All right, bottoms up, y minus 6, y minus 3. Okay. Moving on to the next one. I don't know why I breathed so hard right there, but whatever. All right, looking for a GCF. These 2 terms do not have anything in common other than 1. All of them have 1 in common. So it is a difference of squares. When it is a difference of squares, I'm going to check first. This is a perfect square. This is a perfect square, this is a perfect square. So these 2 terms must multiply to give me this, and they have to be the exact same thing. So that is 4x and 4x. And then these 2 terms have to multiply to give me this, and they're the same number, just opposites. So that's a +1 and a -1. Now, since both of those are linear, this is completely done being factored. If one of them was a quadratic still, or both of them would have to be actually, since it's a difference of squares, then I would try to still factor, but that one's done. All right, next here, first thing I look for is a GCF. There is not a GCF here, so I'm gonna use my organizational X to factor this. A times C goes up top. 6 times -5 is -30. B goes down below, which is 7. I'm looking for 2 numbers. When I multiply them, I get -30, and when I add them, I get 7. So that is 10 and 3. I'm going to make the 3 negative so that when I add them, I get +7. The lead coefficient, or the A value, is 6, so I'm going to divide both of these terms by 6. And then remember, the fractions have to be simplified before you write your factors, otherwise it's not going to multiply to give me this. All right, so simplifying these fractions, The first fraction that I have, 2 goes into both 3 times, 5 times. So this is a 3m plus 5. And then this fraction is also simplifiable. 3 goes into both. 3 goes in here -1 times. 3 goes in here twice. So this is a 2m minus 1. So my two factors are 3m plus 5 and 2m minus 1. And if you used guess and check, great. All right, next one here, same idea, no GCF. So I'm gonna use my organizational X. I have two numbers that multiply to give me positive 36, and when I add them, I get negative 12. So I have 1 and 36, no, 2 and 18, no, 3 and 12, right? 3 and 12, yes, but no. Where am I? I was at 4. 4 and 9, no. 5, no. 6 and 6, yes. Okay, so 6 and 6, but they're both negative because it's -6 times -6 gives me a positive 36. When I add them, I get negative 12. And then divide by your lead coefficient of 4. Okay, fractions are simplifiable. 2 goes into here twice, 2 goes into here -3 times, and then same thing over here. So I have 2p minus 3 times 2p minus 3, or 2p minus 3 squared. I don't like that it's in pink, sorry. 2p minus 3 times 2p minus 3, or 2p minus 3 quantity squared. Either one's fine. All right, last one. Looking for a GCF. Nope, they have nothing in common. So I look to see if it's a difference of squares. 9 is a perfect square, and 49z squared is a perfect square. So this is factorable. The first two terms have to multiply to give me 9. So that's 3 and 3. The second two terms have to multiply to give me negative 49z squared, and they have to be opposites. So positive 7z and negative 7z. All right. And those cannot be switched around. Don't put the z first because you want it to be first. It's not. All right, so this is the same idea, but this is solving, okay? So one of our ways to solve a quadratic equation is by factoring. In order to factor it, it has to be equal to 0, though. So the first thing we're going to do is we're going to get it to equal to 0. Also, we are only going to try to factor it if it has an x squared and an x in it, right? So if you look, x squared and an x squared and an x, so on and so forth, okay? So if it didn't have an x squared and an x, if it just had an x squared, I would try to solve it by square rooting. But since it has an x squared and an x, we are going to try to solve by factoring, okay? So it has to be equal to 0, done. So now you are going to factor it. So look at your 3 terms there, look for a GCF. There is no GCF, so I'm gonna use my organizational X. To factor this, a times c is -4, b is -3. Two numbers that multiply to give me -4 and add to give me -3 are -4 and 1. Lead coefficient is 1, so I don't have to worry about simplifying. This is x minus 4 times x plus 1 equals 0, and now you're going to set each factor equal to 0 and solve each of those equations. So we have x equals 4 and x equals -1. Setting each factor equal to 0 and solving, that's called the zero product property, is that if if this times this is equal to 0, one of them has to be equal to 0. So you set each one equal to 0 and solve. Also notice that we are solving, right? This is an equation and it's solving for x. That's why we have solutions here. As to this is not solving, right? We have no solutions here. All right, here's the next one, right? I see an x squared and an x, so I'm gonna try to factor it, but in order to factor it, it has to be equal to 0. So I have 9x squared minus 12x plus 4 is equal to 0. So we're gonna go ahead and factor this. I feel like we did this problem already, but we didn't. It just seems so familiar. Okay, we had those numbers though. All right, looking for a GCF on the left-hand side there. There is no GCF, so I'm gonna say I need two numbers that multiply to give me -36 and add to give me -12. That's why it seems so familiar. It's just backwards, right? That's -6 and -6. Divide by our lead coefficient of 9. The other one had a lead coefficient of 4. Simplify. 3 goes into both of those. 3 goes into 9 3 times. 3 goes into -6 -2 times. So we have 3 x, I lost my variable there for a second, minus 2 times 3x minus 2, or 3x minus 2 quantities squared. Either one's fine, right? So now I'm going to set each factor equal to 0 and solve, but each factor is the same, right? Both the factors are the same, so I only have to do it once. Add 2 to both sides, divide by 3, and you have x equals 2/3. You only get one solution to this. Let's think about what that means. Okay, solutions are where it hits the x-axis. If it's only hitting the x-axis once, that means that it's also its vertex, right? This one's hitting the x-axis twice, right? So that's why it looks like that. Or sorry, that's why we have two solutions. All right, moving on to the next one here. It's already equal to 0, so check. I look for a GCF in those three terms. There isn't one, so I'm going to use my organizational X. If you want to use guess and check, that's on you. Go for it. I'm looking for two numbers that multiply to give me 30, and when I add them, I get negative 13. Okay, so be careful here because 15 and 2 will give me 13, and 10 and 3 will give me 13, and it can't be both of them. So I have to make sure it's the right one. So when I multiply them, I get a positive 30, and when I add them, I get a negative 30. So if I try 15 and 2, one would have to be positive and one would have to be negative, and when I multiply, I don't get 30 for that, positive 30. So it's going to be negative 10 times negative 3. That gives me a positive 30 when I multiply, and when I add them, I get negative 13. Divide by your lead coefficient of 5. This time only one of our fractions is simplifiable, but as long as one is, you know you're okay. And now you can write your two factors. So this is x minus 2 times 5x minus 3 is equal to 0. Set each factor equal to 0 and solve. So here you get x equals 2. On the second equation, add 3 divided by 5. You get x equals 3/5. So 2 and 3/5. All right, make sure you're not skipping this step, okay? Make sure you're not skipping this step, and also make sure you're not forgetting to write equals 0, okay? Remember, each line, each subsequent line should be equivalent to the one before it. All right, this one right here, I see x squared is an x, so I'm going to try to factor it, but it has to be equal to 0, so I'm going to subtract 3x from both sides and add 5 to both sides in order to get that to happen. So I have 2x squared minus 20x plus 50 is equal to 0. All right, left-hand side looking for a GCF. This time I noticed that there is a GCF. There's a GCF of 2, all right? So I could either factor that 2 out, or I can divide both sides of the equation by 2, all right? On this one right here, I want to point out, I forgot to box this, so I'm going to go ahead and do that. On this one right here, I want to point out that the 2 stayed in your answer because it's, what is this factor to, right? And 2 times this gives me this. This is not what is this factor to, it's solve it. So I'm going to show you dividing both sides by 2 and factoring out the 2 gives you the same answers, okay? I will start by factoring out the 2. So if I factor out the 2, I have x squared minus 10x plus 25 equals 0. Factoring this, all right, two numbers that multiply to give me 25 and add to give me negative 10 are negative 5 and negative 5. Divide by your lead coefficient of 1. So this factors to x minus 5 times x minus 5, or x minus 5 quantities squared. Don't forget about that 2 in front. And then if you set each factor equal to 0 and solve, this has no x in it, so I don't have to set it equal to 0. This has an x in it, but it's a repeated factor, so I'm not going to set both. So I just got x equals 5 equals 0, or sorry, x minus 5 equals 0, x equals 5. Okay, so if we go back to, I'm going to move this down right here. I'm not going to erase it. But if we go down right here, back to where we were, we said that the GCF was 2. So what you could have done is divide both sides of the equation by 2, all right? Remember, when you divide a side of an equation by 2, you have to divide each term by 2. So that's x squared minus 10x plus 25 equals 0. And then you are right where we were right here, right? We're right here. So you get the same solutions because you factor it to this, and then you get this as an answer, okay? One thing that I want to point out If I said solve, either method is fine. But if I asked you to factor this, okay, well, it wouldn't look like this, but if I asked you to factor this, this is your answer, right? Don't forget about that too if you're asked for factors. Okay. All right, the last one right here is a word problem. So let's read through that and then solve for whatever it's asking us for. So it says, using a quadratic equation as a model. A yearbook editor is designing a page layout. The outside dimensions of the pages are 12 inches by 9 inches, which is represented in that diagram there. The white border around the rectangular printed material on the page is twice as wide on the sides as it is on the top and the bottom of the page. Where was I reading? There we go. The area of the printed matter is 56 inches squared. What are the dimensions of the printed matter? So I have to come up with something to label this length and this width. So one piece of information is that they didn't give me, but like it's my unknown really, is that they said that this distance right here is unknown, so we'll call it X. So that means that this is also X, okay? And then this distance right here is twice as long. So this is 2x and this is 2x. I don't need to draw it everywhere, but I'm going to. 2x, 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 right here. And this is x right here, x. Okay, so I want to come up with something to call this and then something to call the other piece. Okay, so if you look, the whole thing is 9, right? That's 9, but I have to get rid of this and this. So this is 9 minus 2x. And then the same idea here, this whole thing is 12, and then I have to get rid of this and this. So that's 12 minus 2x, which is minus 4x. So now if I want to find the area of the printed matter, or let's see, what are the dimensions of the printed matter? So that's this right here. And what is that, 56? The area of the printed matter is 56. All right, good. I know I'm talking to myself here. But I need to find x, right, to find the dimensions. So let's go ahead and write our equation here. So we have this times this is equal to this. So we're going to do 12 minus 4x times 9 minus 2x is equal to 56. All right, well, right now this does not look like a quadratic, but let's expand it by multiplying so that it does look like a quadratic. So 12 times 9 is 108. 12 times negative 2x is negative 24x. And negative 4x times 9 is negative 36x. 24x, all right, negative 24x and negative 30x is negative 60x. And then negative 4x times negative 2x is positive 8x squared equals 56. So now this just looks like a problem from up here, right? This is a quadratic with an x squared and an x. I want to try to solve it by factoring, but it's got to be equal to 0 and written in standard form. So I'm going to subtract 56 from both sides, and I'm going to write it in standard form. So I'll write the 8x squared first, and then I have minus 60x, and then 108 minus 56 is 52, so plus 52 equals 0. All right, so now I got to solve this. This is much more manageable looking, right? So first thing I'm going to do is look for a GCF, and I noticed that all three numbers, well, 0 is also divisible by 4. So I'm going to start by dividing both sides of the equation by 4 because this is an equation and I can just make those numbers smaller and easier to manage. So now I have 2x squared minus 15x plus 13 is equal to 0. All right, so now I'm going to try to factor this. So I'm going to use my organizational X here. A times C is 26, and B is negative 15. So I need two numbers that multiply to give me positive 26 and add to give me negative 15, which are negative 13 and negative 2. Divide by your lead coefficient of 2. That simplifies to negative 1 over 1. So now I have my two factors, 2x minus 13 times 2x minus 1 equals 0. And now I can set each factor equal to 0 and solve. So I have this one here, 2x minus 13 equals 0. 2x minus 1 equals 0. So this gives me, add 13 divided by 2, you have x equals 13 halves, or x equals 6.5, right? And the reason I'm thinking of that is because, remember, these are dimensions and I have to think about that. And then this is x equals 1/2, or x equals 0.5. Okay? Oh, no, I didn't simplify that, because look at this. This doesn't make sense. I didn't simplify it correctly. It's 1 over -1, right? So this is x equals what? I was like, that doesn't make sense. Okay. And let me fix that, because that's where I saw that it didn't make sense, was in my factoring. When I looked at that, it wasn't an equivalent to 2x squared minus 15x plus 13. Okay. All right, so I have x. Now let me remind myself of what it asked me for. What are the dimensions of the printed matter? Okay, so I have to plug in 1 and I have to plug in 6.5 to see those dimensions. Now, I could already see that 6.5 is not going to work, because if I plug in 6.5 here, I get, well, a negative number, right? So 6.5 is out. That's going to give us a negative answer, right? And instead, I'm going to use 1. So I'm going to do 12 minus 4 times 1. That's 8. What was this, in inches? Inches. And then the other one is 9 minus 2 times 1, which is 7 inches. So the dimensions of that printed area, or that printed matter, is 8 inches by 7 inches. Okay, and there you can see how you can use quadratics to model something. All right, that's it for factoring notes. Go ahead and try some practice on your own.